So mathematicians facing me and showing that you can really see. Brandon, making sure you're sitting all the way on your bottom so people behind you can see. And Prospero, if you're at your seat, you're turned this way so that you can really see. I know where they are. Yeah. Okay. So mathematicians. I'm going to ask a few people to check themselves. Make sure you're sitting all the way on your bottom. Gerard, all the way on your bottom. Jorge. Great. Bless you. So mathematicians, we've been looking at multiplying numbers and specifically at different strategies to help us figure out how to solve multiplication problems. And one of the things that we've been thinking about is drawing arrays to help us solve, right? And we know that we can multiply numbers in any order. We know that we can multiply numbers in any order to help us solve problems, and we'll still get the same answer. So how many different ways can we put these numbers in order? So right now we have 3 times 5 times 2. Is there another way that we could put these numbers in order to multiply them together?
15 times 2.
So is there another way that we could put these numbers in order? Because I noticed that you're already starting to solve them, and I'm just... 3 times 2 times 5 is another way we could put them in order?
2 times 3 times 5.
2 times 3 times 5. So before I move those, I'm going to go ahead to my recording sheet and record the first way we have them in order. Okay? So we have 3 times 5 times 2 equals something. We haven't solved it yet. I know some of you have been thinking in your mind about what the answer might be. And what we're going to do is to show what two numbers we're going to multiply together first. We're going to put what's called a parentheses around them. Make sure your eyes are up on the screen. A parentheses tells us what numbers to multiply together first. So I know first I'm going to multiply 3 times 5, and then I'm going to multiply by 2. And we'll solve in a minute. So Leandro, can you tell me one more time, what was the other way we might put these numbers in order to multiply?
3 times 2 times 5.
3 times 2 times 5. So that's another way we could put these numbers in order. And I'm going to go ahead and record that as a second way I might solve this problem. Mathematicians, is there a third way that I might put these numbers in order that we haven't found yet? Take a look at those numbers. Is there a third way that we haven't written yet that we could put those numbers in order?
30.
Or that we could multiply those numbers? Lizeth, what are you thinking?
Because I told you. 2 times 5 times 2.
2 times 5 times 3. So you know what? Oh, I'm going to make sure everyone's really listening and has their eyes up here. I'm going to write these numbers the same way, but I'm just going to put a parentheses around 2 times 5. Because that's what Lizette said we were going to do first.
Parentheses.
Equals something. Okay.
More than 3 times.
Great. So mathematicians, we've been talking a lot about drawing arrays to help us solve. And today we're going to take a look at how we can multiply 3 numbers together. And it will show us that we can multiply numbers in any order. We can multiply numbers in any order and still get the same answer. So let's take a look at 3 times 5 times 2. When you multiply 3 times 5 times 2, since 3 times 5 is in parentheses, I know I'm going to do that part first. So this tells me that I'm going to draw 3 groups of 5. 3 groups of 5. So 1, 2, 3, 4, 5. That's one group. 1, 2, 3, 4, 5. That's 2 groups. And 1, 2, 3, 4, 5. That's 3 groups of 5. Mathematicians, what does that equal? 15. 3 times 5 is 15. I heard a lot of people saying that earlier. But, Prospero eyes here, but it's 3 times 5 times 2. So it's this whole thing 2 times. Not 2 more times, just 2 times. So it's 3 times 5 times 2. 2 times. So I'm going to draw that again. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 2 groups of 3 times 5. And if I added that all together, someone with a quiet hand who's already figured it out, because I know some people already calculated this before. Warren, what did you find? 30. So 3 times 5 times 2 equals 30. Now mathematicians, I'm going to ask you in a moment, you're going to think to yourself, how would I show 3 times 2 times 5? How would I show 3 times 2 times 5 drawing an array to solve? Okay. How would I show that in this problem? So take a quiet minute to think to yourself, and then you're going to turn and talk to a partner. You're taking a quiet minute right now to think to yourself? When you have an idea, put a quiet thumb at your heart. So what would this look like? Because I'm going to ask a volunteer to come on up and draw it in a minute. Quiet thumb at your heart when you have an idea about how this would look. 3 times 2 times 5. So mathematicians, please turn to somebody next to you and talk to them about what this would look like, and I'm going to listen in. Okay? Go ahead, turn and talk.
Okay.
So Gerard, you're going to turn to somebody next to you. Okay, turn around, turn around, turn around. Okay, turn around. Adrian. Michelle, behind you. Hi. So we have 3 times 2 times 5. So what would you draw? Take a look at Prosper. So what would you draw?
I don't have it.
So 3 times 2 times 5. So what would you draw first? And then what? And then what would you do? You said you draw 3 groups of 2, and then? And then maybe 3 groups of 5? 3 groups of 2, 5 times. I wonder what that would look like.
You're gonna stink. Dude, I don't have better sword. I don't have it. Mom,
So they can equal 30, so you think you get the same answer? Would it look the same as the first one? It would look exactly. Oh, there's different groups, so it's not going to look exactly the same as the first time. 5, 4, 3, 2, 1. Mathematicians, great conversations. I heard from a few different groups. I saw some people moving to talk to other people, and I heard some really interesting ideas about how you might show 3 times 2 times 5 using arrays. I'm looking for a brave volunteer, somebody who's going to show courage, to come on up and show how you would show this problem, how you would solve this problem. Okay, I see a lot of people volunteering. Remember, if you're not coming up, that you're really showing good attention up here so that you know what to do when you go to independent work. Warren, go for it. So Warren, make sure that you talk to us while you're working. And if you're making a mouth noise, you have 1 warning.
3 times 2 is 6. And an array of 6. Of 3 times 2.
And it's 3 times 2 times 5. So what are you going to do next? And Marcus and I were having a conversation about this too. So what do you think you're going to do next?
Do it 5 more times.
5 more times or 5 times total? It's 3 times 2 times 5. If you need help, you can ask from another mathematician. Mathematicians, if Warren needs help, make sure that you're there to offer him help. You can raise a quiet hand if you think you know, and maybe Warren call on somebody who hasn't talked yet.
Samila.
You have to get 3 pieces of 2.
Warren, did you understand what Camila was saying? Okay, so Camila has a really good start. You couldn't hear what she said, so you can say, excuse me. If you're not sure, you can raise a quiet hand and ask, and either add to it or ask Camila to repeat what she said. Warren, can you call on someone else to add to what Camila said?
Lisa.
So the number that she said on the edge, so on this side, you put the 2, right? You put 2 on this side and 5 times in a row.
I have an idea.
Yep, Warren, go for it.
Darwin?
Uh-huh. David.
3 times 2 is 6, and 6 times 5 is 30.
So how many groups does he need to draw?
4, 5, 2, 5.
How many groups of 6 does Warren need to draw?
5.
5 groups of 6. David, please come sit here. So how many groups does he have now, mathematicians? 2. 2 groups of 6, because he has 2 groups of 3 times 2.
It would be easier 6 times 5.
I'm noticing that you have another way that you're thinking about drawing it. So Warren's going to finish up and then...
And 5. That's the same thing.
And then we're going to figure out how many he has all together.
5 times 7. 5 times 5.
Now how many groups does he have?
4.
4 groups. And I notice some people are really keeping track. Like I see Rochelle really counting over there to see how many.
10.
Last reminder.
5 times 11.
Now he has 5.
5 times
5 groups of.
6.
And let's get a quiet hand. I see a lot of people counting now. How many does he have all together?
30.
Oh, and he's rewriting. Oh, 5 times 6 equals.
It's 30.
500.
5 times 6 equals 30. Warren, where did the 6 come from?
That would be 50 times 6.
3 times 2.
So 3 times 2.
And inside the box.
So mathematicians,
I already knew this question.
I know you said. Warren, thank you so much. Great job. I'm waiting for all eyes on me. I know you said that there's a third way to solve this. We're not going to do this right now because you're going to have an opportunity right now to practice this on your own. So mathematicians, when I excuse you, you're going to go back to your seats. You're going to, on your way to your desk, Brandon, Ice here, you're going to pick up a blue piece of paper. I'm going to ask for a volunteer to be the first one to do this just to make sure everybody knows what to do. So when you stand up, you're going to watch me and then you can volunteer. You're going to stand up, you're going to walk over and you're actually going to pick up a green piece of paper first, and you're going to show how many different ways can you solve the problem at the top. So just like we did here, because we know the important thing, mathematicians, is that you can multiply numbers in any order and still get the same answer. Do these 2 arrays look the same?
Yeah, no.
Do these 2 sets of arrays look the same?
No.
But is the answer the same?
Yes.
Yeah, the answer is the same. So we want to see how many different ways we can show multiplying these numbers together and we'll still get the same answer. So I'm looking for a volunteer who can show me what to do. Everybody else sitting in one of the 5 ways we talked about. So what are you thinking about? What are you thinking about? You watched Warren at your table doing one of these problems. So what's the first thing that you're going to think about to yourself?
2 times 3.
What order can you put those numbers? Could you do 2 times 3 first? You could do a 2 times 3 first. So how? Okay. So talk to each other. What part are you feeling stuck on?
This 6, that equals 6.
Oh, so Miss Hofmayer.
6 times 5.
4.
I mean 6 times 4.
What do you think?
Yes.
Talk to each other. Brandon, what are you thinking about? I noticed that you wrote a parentheses. What is the parentheses going to tell you to do?
Multiply 2.
Then we make an array. 3 times 2.
Oh, so you're going to do that part first? Okay.
I am scared.
So you did 2 times 3 is 6. And then what's your next step?
6 times 4.
Yeah.
Okay.
Also, we're not doing this part.
So, Darwin, can you talk to Paulina about what you're thinking about here? So she did 2 times 3 is 6. Now what's the next step going to
6
be?
times 4 equals something.
Okay, so how would you figure that out?
Drawing a race.
So I notice it's pretty quiet at this table. What are you guys thinking about?
I'm thinking about making 2 groups of 3.
2 groups of 3? Okay, and then what?
And then we're gonna add them.
How many times?
4 times.
You're gonna add them 4 times.
3.
Okay.
Can we put 1 equals?
Can you?
Yeah.
Yeah?
And plus.
Okay.
No.
What are you thinking about,
I'm gonna go
Shahira?
Do 3. There's 2 groups.
Mm-hmm.
There's 2 groups. And you should have this
Okay. Yep.
And then we should do
And then you're gonna do 4 more groups of
that
what?
one is last, so you have to do 2 groups of 3. Like 3. You put 3 in 2 boxes, in 2 groups.
How many are in one of these groups of 2 times 3? 6. So how many groups of 6 are you gonna draw? 4 groups of 6. Okay, and how many groups of 6 do you have so far?
Yeah, but just 3, so that's up because it 1, 2, 3, 4. It's 4 already times.
How many groups? So she said 2 times 3 times 4.
Oh, okay.
Oh, okay. So you have 2 times 3 times 4. Looks like you guys are doing some good thinking. I'm gonna let you keep thinking about it. Yep.
7, 8, 9. So I was right.
So now you have 4 times 3 times 2. So you've moved your numbers into a different order. I wonder if you're gonna get the same thing.
We don't need a weird way.
Hi.
We don't need
So what's your first step? What are you thinking about?
Hey, can you pass me the pencil box, please?
And you know what, Gerard? You can actually definitely talk to the other people at your table. So Mahalia, can you pause for just a minute? I know you're doing some counting. Can you talk to Gerard a little bit about your thinking? And Gerard, make sure you're listening.
We don't need an answer. Okay. We only have one. Hey, so I'm gonna go. Okay. Oh, poor little baby. Hey, where's my... I saw the baby one. Oh, yes. Just a tree.
So what are you thinking about doing first? You have 2, Gerard. Remember you did your warm-up this morning? And you had 2 times 3. Here you have 2 times 3 times 4. Pretend that the times 4 isn't there. Can you draw me an array that shows 2 times 3? 2 groups of 3.
4 times 3. 4. No, 4 times 3. Let's put like 1 times 2.
And so it's 2 groups of 3 4 times.
3 times. What the?
This is 1 time. Can you do it 4 times?
Okay, so 2. I'm gonna do 4 times 4 times 3. Yeah, times.
So mathematicians, once you've solved it one way, I'm going to ask you to go and pick up the yellow sheet and solve it and do another set.
Wait, Miss Hofmayer. Miss Hofmayer. Yeah.
I'll be there in 1 second.
Someone punch me if it's not. It equals 12. It's equals everybody knows that. Pinch me. So I can see how I'm dreaming. Okay, I'm not dreaming.
We did 4 times 2. I did 3 times 2.
Wake up.
Hi, David. So I noticed that this morning you did, David, this morning on your warm-up, what did you do? Erase, right. So let's take a look at this problem.
You guys
again.
are friends.
2
I
times 3
thought you
times
guys
4.
weren't.
And Andres as well. 2 times 3 times 4. So pretend like the times 4 isn't there for a minute. And it's just 2 times 3.
First we like. We're not talking about that.
So how would you draw that?
Cameras are just trees.
Two
Okay,
groups
we
of
have into trees.
How would you draw 2 groups of 3?
I am talking about that.
Yeah, how would you draw 2 groups of 3 as an array?
Come on, let's just play. How is it like this? Go play. Why is it like this?
Think about how you would do it. How can you make sense of 2 times 3
stick
for
figures.
yourself?
Oh, I didn't do it. Does this look
Just like you were thinking about in our work today.
1, 2, 3. 1, 2, 3. No, I just get 1, 2.
Absolutely, yes. Yeah, if you finish the first one, you can go on to the second one.
Yeah, I just finished. I know her birthday
So table 5, what are you guys thinking about? I noticed that you're all working. Some of you are working on the green sheet, and some of you are working on the yellow sheet. Have you talked at all about your work?
Adrian, look, you forgot.
Or are you just working? Okay. No? So Eduardo, what are you thinking about right now? Just explain what you're doing right now. It looks like you're doing some good thinking on this problem. What are you doing? Yeah. So I'd love to see you do your best to try to do a couple problems right now. Can you do that?
2, 3, 4.
Okay, awesome. Okay, thanks for trying. Yeah.
I know, right?
Okay. So, sorry. So, Eduardo, what are you thinking about here?
1, 2, 3, 4, 5, 6, 7,
3 rows of, how many are in each row?
1, 2, 3, 4, 5, 6.
You tell me, is it 3 or 4 in each row? What did you draw?
Yeah,
What did you draw?
it's easy for you.
You have 3 rows of, we're going to go to the table.
Mira, I'm not sick. I'm working in it. 7, 8,
How many are in each row, Eduardo?
13, 14, 15, 16, 17.
Okay, so you have 3 rows of 4, right? So you have one group that is 3 times 4. How many of those are you going to draw? It's 3 times 4 times 2.
24. No, they're not. No, oh yeah, on that one, but not this one. Then we did it all right.
You have to, so you need to do 3 times 4 times 2. So when you put it in parentheses, that means this part, this whole thing, 2 times. So here's 1 time. So go ahead and erase those 2 that you just added. That's 1 time, and then you need to draw it another time. A whole array.
Oh, you're
Does that make
counting
sense?
it again?
So this is 3 times 4,
Oh,
and then 3 times 4 times 2.
No, it
So
isn't.
you need to draw it again.
16.
And then figure out what all of that is.
She makes mistakes.
Okay? All right. And the same thing on these ones. You got a really good start. Locking feet, please. So mathematicians, I said it once before, but I'm going to say it again. If you finish the green sheet, you don't have to ask me. You can just go get the yellow sheet. Yeah. It's a little harder. Yeah. So you're trying to think of a third way. So thinking about the order that you multiply the numbers. So far you've done 2 times 3 times 4. And then I noticed here you wrote 6 times 4. Where did the 6 times 4 come from? Can you use your words to explain?
1, 2, 3, 1, 2, 3, 1, 2.
You got the 6 from that 6. So basically you took your 2 times 3 and then you did it 6 times, and that's how you got this answer? Okay, great. So here then, I'm wondering if you can put these numbers, if you can multiply them in a different order this time. So you could write them the same, but then multiply them in a different order like we did up at the top.
It's 36. That's obvious. You can just put 36 in all of them. And then 1, 2,
So I noticed that you have some different ways of showing your thinking. Yeah. Yep. Great. So now you've put your numbers in a different order. So are you gonna? What part are you gonna do first? Because the part you're gonna do first, you want to put in parentheses. What are you gonna do first? What two numbers are you gonna multiply together first?
30, 31, 32, 33, 34, 35, 36, 37, 38, 39.
So you want to show which two numbers you're gonna multiply together first. So which two are you thinking about multiplying together first?
49, 50, 51, 53,
3 times
53,
4. So go ahead and put a parentheses around that.
57, 57,
I want the other one.
Okay. So you're gonna do that part first. Great. You're done with all three ways. See if you can find a third way to multiply them together. Right? So you're trying to multiply 2 times 3 times 6. So this right here.
Write down the same on the other one.
Oh, sorry. 2 times 6 times 3. But could you multiply it 2 times 3 times 6? Could you multiply it that way? Why don't you try that here? 2 times 3 times 6. So go ahead and write that there.
Exactly. Times 3.
So you've got 3 times 4. How many times?
If you're not gonna copy
So
it,
this is 1 time. So you can put blocks around that.
2.
Now you need that whole thing again.
2 of these. 1, 2.
Hey, write my name.
Oh, dang. How are you going to do that?
Can we switch me and my list? We're gonna
Dang
switch
is okay.
tomorrow.
But thanks.
Because she wants to
All
be
right,
with my
pull your chair in, please.
What the? 36.
Okay. Great. So I noticed that you did 2 times 3 equals what?
Can we?
2 times 3 equals
What? This is too easy.
It's 20.
1, 2,
6, right? You drew 6 here. And then you need to do that 4 times. So that's 1 time, and you need to do it 4 times. So David, it looks like you and Andres maybe talked about this a little bit. So you've done 2 times 3 1 time, and you want to do it 4 times.
1, 2, 3, 4, 5, 6,
Yeah.
7, 8, 9, 10, 11,
I know.
12,
How's it going, guys? Bad, you're feeling confused? Right, we've talked a lot about persistence. So right now it looks like you're showing persistence. I see you trying something and then trying something else. So talk to me about what you're thinking about, Leandra.
First I did 4 times 3. There's no 4.
Oh, but there's no 4 there. So where were you thinking about doing 4?
2, 3.
Where did the 4 come from? Is there a 4 in this problem?
1, 2. This is getting harder.
No. Okay.
1, 2, 3.
So I noticed that. Can you tell me what you wrote here?
Just because I copied 10.
Times 3. Okay. So I noticed that you put your numbers in a different order this time. Okay. So what are you going to do first? What did you put the parentheses around?
I said just because you guys are doing it together. 80.
What's wrong with 80?
Yeah. I know. I didn't say it was wrong. She was like,
55, 60, 65, 70, 75.
4 times 4.
What do you think?
5, 10, 15,
It's
20,
2 times 3
30.
times 4. So if you put a parentheses, that's basically what you did.
Thank you.
You put a parentheses around 2 times 3. So you did that first. And now you're going to do this 4 times.
Yeah.
Okay, let's see it.
Why are you copying this phrase?
I did. Just me.
I'm talking because you're doing the first one.
So explain what you did today.
So what? So what?
Okay.
Because you go fast.
It's because it's okay if she can't go that fast.
No. Then you do a mistake. I already
Okay.
did the mistake.
So you have 6 in each row.
Then, what are you telling
And
me?
how many rows of 6 do you have here?
6, so I did times 6.
You have 3 groups of 6.
There's a Y here. There's a Y.
And you did it 2
for all of
times.
us.
not
Nobody
for
talks
So
to
you
each
did
other.
3 groups of 6.
Unless you're a partner.
2 times.
Unless
How
you're
would
a
that work as
partner.
an equation? If you were going to write
Okay, there's a
3
wall
groups of
here
6.
cutting this way, and there's a wall here cutting this way. No one can talk to each other, okay?
Is that what you have here? Do you have 12 3 times?
Cutting. So you
What do
guys
you
can't
have
talk
here?
to her.
2.
Yeah.
3 times 6.
Yeah, okay.
Go ahead and write that. 2 times 3 times 6.
That's not fair that Ida doesn't get to talk.
And then what part did you do first?
Now.
You were going to put a parentheses around it.
So that
You did the 2 times 6
So
first.
that means
What did you do first? What did you draw first?
Oh wow.
3 times. You did 3 times 6 first. So where would you put the parentheses? You got it. So this shows what you did, the work you did. Do you see how that matches? So you did 3 times 6 first, then you did that. Leandro 2 times, right? What about here? Can you explain this one to me now that we've talked about that one?
No, for you.
Can you show me? So I'm looking. Okay, talk to me about this. What's in this box?
Ready, set, go. 1, 2, 3. Let's put it.
How many are in each row?
No, 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 no.
Good. So I see. So remember that as you're thinking about this, you want to think about the order that you're multiplying the numbers, right? Did you get the same answer here that you got there? Did these two have the same answer? What did they both equal? Okay, so make sure you write the answer here. Do they look the same? No, they look different, right? But you still got the same answer.
Who cares?
So mathematicians, about 5 more minutes. I'm seeing some really great focused work. People trying different things, showing different ways of solving. Yep. Okay. Wow, I noticed that you're really thinking about what numbers you're going to multiply together first. So talk to me about what you're thinking. You're not sure what to do first? So when you draw an array, how would you draw this as an array? Just this one. Don't worry about the 4. How would you draw 3 times 2?
Can you please be quiet?
2, 3. How many times? 2
I
times.
do
Go ahead and
that
draw
on
that.
purpose.
Go ahead and draw that. 1, 2, 3. And then you're going to do that how many times?
It's annoying.
4 times. So this is 1. And then how many of those are you going to do? How many of those do you have now? 2. Great, you're on it. Drop it. All right, what's your next step? What are you thinking about?
How could you help me? Just put 4 and 5 and that's it. Just put 5 here, 4 here.
What are you going to do first?
Teaser. Everybody knows
2 times 2 times 6 first, and then times 3. So go ahead and write that with your parentheses. Let's see how you would do that. 2 times 6 times 3, and then where are you going to put the parentheses? That tells you what to do first. Yep, you want to do that part first? Okay. So what are you going to draw first? 2 groups of? 2 groups of? How many in each group?
I'm on the next one now.
You got it. Awesome. So how many is that all together?
Hey, come in.
So 2 times 3 is 6, right? That's how many are in a group. And then you did that 4 times. How many times did you draw it? 1, 2, 3, 4. Oops. Okay. You only need it 4 times. So I noticed you guys figured out how to do it one way. Can you multiply those numbers in a different way? Oh, close. Yep, you're just going to take 1/10 off of that. Good. Quickly, yes. So David, I noticed that you multiply these in one order. Can you try multiplying them in a different order? So. Nice.
Right now I'm at 60. This is easy.
Hey, how are you doing, guys? Good. Good persistence. I know the blue paper's tricky, but you guys are doing some good thinking. So go ahead and if you figured it out in your head, I want you to write down the way you thought about it. Well, we've done that a lot, right? Think about what you. you're doing something in your mind that's going to help you get that number. So that's what I want you to try to capture on your paper. If it's not an array, then thinking about what it is.
102.
Is it? Okay, then draw what you see. Quick. I know, but in your mind, draw.
It's gonna be all
Quickly. Yeah. Okay, 1 more minute, and then we're going to meet on the carpet. There, on your red paper. Awesome. No more bathroom break. We're almost done. Great. Can you quickly, because we only have a minute left, see if you can figure out one more way, one more order to put those numbers in. You have 2 times 3 times 4. Yep, this is math. So you did 3 times 2 times 4. Can you show one other way to multiply those numbers?
We did 6 and I did 4. 1, 2, 3, 4, 5, 6, 7, 8, 9.
So you did 3 times 2 times 4. What's another way you could put those numbers in order?
I did 2, you did
A different order. Same numbers, but different order.
Look, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13, 14, 15, 16, 17, 1, 2, 3, 3, 4.
No, I'm just asking you in this column. Can you put these numbers in a different order? What order would you put them in? What would it be?
Because you did it 3 times.
2 times 4 times.
And I did 2. Look.
Go ahead and write that. 2 times 4 times 3.
2.
Okay, so what are you going to do first? You're going to put the parentheses around what you want to do first.
2. You're on your paper.
You tell me. What are you going to do first? Put parentheses around what the part you're going to do first. You get to choose.
He doesn't have to.
You get to choose what part you're going to do first.
Dude, that's okay.
What part? Just show me the 2 numbers you're going to multiply together first. 3 times 4 or 2 times 4? 2 times 4. So go ahead and put a parentheses around that because that's going to show you what to do first. Yep. And now you're going to go ahead and do 2 times 4. Do that. How? You know how. 2 times 4. Yep. So how would you show that? 2 times 4.
I know what it's This one's just really hard.
Very quick. Can you actually wait just like 1 minute because we're about to have our closing conversation. You can go. Okay, so let's put the pass away. Okay. So it's 2 times 4 times 3. So what does that mean? How many times are you going to do this? How many times are you going to do this? 3 times. So keep track.
104, didn't you? Camila, I got 110.
I noticed you wrote your numbers in some different orders. Do you want to try to solve one of those?
40, 45, 50, 51, 60, 65, 70, 75, 80, 85, 90, 95.
You tell me, what are you thinking about? Tell me what you're thinking about.
Like 5, 10, 15, 20, 30. Also, it's 105.
So Darwin, you can definitely talk to her about what she's doing. You don't have to tell her she's doing it wrong. You can say, I'm thinking. No, you can say what you're...
55, 75, 76, 77, 78, 79, 80, 81, 82, 83, 84, 85, 86, 87, 88, 89, 90, 91, 92, 93, 94, 95, 96.
Okay, I notice a lot of pencils still moving. Let's put pencils down. Eyes on me in 3, in 2, Iran in 1. Have a seat. And pencils down, table 3. Pencils down. All right, so mathematicians, I saw a lot of different people trying different strategies. I'm going to ask you to leave your papers where they are. Okay, you can put your pencils away, and we're going to have a quick closing conversation on the carpet. So just leave everything where it is, push your chairs in, and come to the carpet.
Camila, you better stop. Camila. Seriously, so steady. No, but it's not fair when she she's still working on how to picture our current
Have a seat. I'm looking for people who are making a really good choice about where they're sitting. I noticed Andres found a spot that's really going to help him focus. I noticed Andres and Jorge. Jorge, I'm going to ask you to find a spot that's not next to Warren. Hey, Darwin, I'm going to slide in here for a minute. So mathematicians, we're going to have a conversation about what we noticed as we were solving these problems. So I'd just like to hear, first of all, what did you notice as you were solving one problem in the 3 different ways? What were some things that you noticed as you were working? Was that, yeah?
In some there was not enough, like you had to repeat, like 3 times 5 times 2, you have to do that again because there's like no more. What?
Brandon, what did Lizeth just say? If you're not in a spot where you can focus, make sure that you are. I'm going to put a piece of student work up so that we can really see. So Warren, I'm going to put your paper up, if that's okay. All right. And so this is, Warren took a look at 2 times 3 times 4. And let's talk to somebody else about what you're noticing, because everybody solved this. Everybody worked on the first problem. So let's see what we noticed. What are you noticing, Jorge?
That he put lines in the middle of every circle.
Okay. And what did that help him do?
Counts.
Okay, what is he trying to count?
He wouldn't mess up.
Okay, so the lines helped him keep track of each array.
Yeah.
Great. Lizeth, did you want to add to that?
He made other sentences.
Can you say more about that?
He made he made the
Arrays.
arrays, but how he saw it, it was 6 times 4 equals 24, and the different part is that the one at the top is 2 times 3 times 4.
Mm-hmm. So you're noticing that the equations
Are different.
are different in each row, in each column, right? And he's solving part of the problem.
But it's also the same answer.
Can you add to that, David? What are you noticing? What's the same answer? All the equations have the same answer. Mathematicians, if you notice that all the equations have the same answer, put a quiet thumb up. Eduardo, did you notice that all 3 equations when you were solving them had the same answer when you were doing your own problems?
They're the same problem.
So I'm seeing a lot of thumbs up. That's showing me, Gerard, that's showing me that everybody saw that those problems have the same answer. What else are you noticing besides that every problem had the same answer? Mahalia.
Well, I actually have something to say, like how I can check this work.
Sure.
I know that 2 times 2 is 6, 6 times 4 is 24.
Say that one more time nice and slow, and then I'm going to ask somebody to repeat what you just said.
I can check this work by saying 2 times 3 is 6, 6 times 4 is 24.
Somebody who heard what Mahalia said, who thinks they can repeat that. Let's hear from somebody new. Darwin, what did you hear Mahalia say?
That she could check the work by 2 times 3 is 6 and 6 times 4 is 24.
Okay. Let's have one more person in your own words say what you just heard. Let's have somebody different say what you just heard. Leandra, what did you hear?
I heard that Mahalia said that 6 times 4 is 6 is 24 and 8 times 3 is 24. What? 8 times 3 is 24.
Okay, somebody repeat, because you just said something slightly different, but you're thinking, you're like building on that idea. Can somebody else say what they heard Leandro say? Camila, nice loud voice. What did you hear Leandro say? Okay, so you heard them say something, but you're still trying to figure out exactly what they're talking about. Yeah. So mathematicians, one thing that I'm noticing is that a lot of you did a great job drawing an array like 2 times 3. 2 times 3 is 6. And then the tricky part, and what we were working on a lot today, is adding that last piece. 2 times 3 is 6, 4 times, right? 4 plus 4 plus 4 plus 4. 6 times 4 is 24, right? Or, right, because it's repeated addition too.
Times.
4 times 5 is 20 and then plus 4.
4 times 5 is 20. Plus 4? Plus another 4 is 24. Yeah, yeah. So, one thing I just want to make sure everybody understands. So we all agree that every single problem has the same answer?
Yeah.
Do they look the same?
No.
No. So even though every problem has the same answer, it doesn't matter what order we multiply the numbers in, right? We can multiply them in any order. Eyes here? It doesn't matter what order we multiply. We're still going to get 24 every time on this problem, but the way it looks is different. And that's going to be really important for our work tomorrow because we're going to be looking at real world problems, right? Where you might use this to help you solve them, okay? So that's what we're going to be thinking about tomorrow. Great thinking today. Good job, you guys.